In this video, we will be reviewing Chapter 4, which covers 5 of the triangle congruence theorems, as well as some additional theorems as well. So first, in Section 4.1, we discussed 2 theorems. One was the triangle sum theorem. So what this says is the 3 angles of a triangle, the measure of the 3 angles of a triangle add to 180 degrees. So you should be able to find the missing measure of an angle or solve for x by setting up an equation. So here I have the 3 angles of this triangle, 2x plus 4, 120, and 20 degrees, and I want to go ahead and take the sum of those 3. So 2x plus 4 plus 120 plus 20, and all 3 of those angles should add up to 180. So my next line, I combine my like terms and I get 144. And then I can subtract 144 from both sides and I get 2x equals 36, and divide by 2, x equals 18. So if this problem were to solve for x, that is how you would do it. If it's asked simply for the measure of the missing angle, so let's say I didn't have that 2x plus 4 there, and it asks for the missing angle, all you would do is take 120 plus 20 and get 140, and take that away from 180. So this missing angle should be 40 degrees. The exterior angle theorem, we went through a proof of this, but really in short what it says is the 2 non-adjacent angles to an exterior angle. Right here is the exterior angle, and here's the adjacent interior angle. So we want the other 2 interior angles. The sum of those 2 is going to equal the exterior angle. So if I take x plus 20, that is going to equal my exterior angle, 2x minus 25. And this problem, you do need to solve for x, but actually what they want you to find is the exterior angle in the very last step. So first we need to solve for x by subtracting x and then adding 25 to both sides. Combining a couple steps here, so x equals 45. Alright, and then I need to substitute that value back in for x to get my exterior angle. So 45 replaces x. That becomes 90 minus 25, and that comes out to 65 degrees. So that exterior angle is 65 degrees. So what's important on that one is make sure that you read your directions to actually answer the question. 4.2 discusses triangle congruence. So a couple of example questions would be for you to name all of the corresponding parts. If that were what you needed to do, you would say angle A. So it says triangle ABC is congruent to triangle XYZ. So angle A is congruent to angle X. Angle B is congruent to angle Y. Angle C is congruent to angle Z. I know definitely there is at least one question that asks you to do this, so you do need to list out everything. Side AB is going to be congruent to XY, and BC is going to be congruent to YZ, and lastly AC is congruent to XZ. So they are all in corresponding order, so if you were to go first and last there, you'd need the first and last in that one. Alright, so to actually use this triangle congruence to solve for an x, you could use your knowledge of how many degrees the interior angles of a triangle add up to in order to solve for angle A. Since I know angle A is supposed to be congruent to angle X, I could solve for angle A here. Now I'd take 45 plus 65, and angle X is equal to angle A, and I could take those 3 angles. I could go ahead and say this is 7x, 180 degrees. So 7x plus 110 equals 180. 7x equals 70. And last but certainly not least, x equals 10. So that's just an example of a couple of problems that you might see. Sections 4.3 to 4.5 discuss our 5 congruence theorems. So we did side, 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 angle, side, hypotenuse, leg, angle, side, angle, and angle, angle, side. I told you that one of the vocab words that's going to help you a lot is whether a side or an angle is included. So you are going to have to either list what theorem it is, or can they be proven congruent, and by what, or in the correct order, what triangles are congruent. So that would be writing a congruence statement. For example, triangle blank is congruent to triangle blank. That's a congruent statement. So looking at my first example, example 1 right here, I do have two sides, so I'm just going to kind of mark that down. I do have two sides, and so that's going to eliminate angle, side angle, and angle, angle, side. And I don't know that it's a right triangle, and I don't have a hypotenuse, so that gets rid of hypotenuse leg. I don't have a third side, so if it were to be one, it would be side angle side. So do I have an included angle? And I actually do. It's hidden. It's not marked, it is unmarked, but I do know that those vertical angles are congruent. So side angle side would work for this example. For the second example, I only have one angle that is marked, so that gets rid of angle, side angle, and angle, angle, side. And it does happen to be a right triangle, so is the hypotenuse marked? It is in both of them, and I do have a leg that's marked. So I could use hypotenuse leg, or I could use side, angle, side as well. Oops. And I actually do have all three sides. So this is one where you have multiple options. So you would have your choice of how to prove that one congruent. And then the last one, I have two angles marked. So that eliminates all choices except for these two. Two angles are marked. And so then you're going to ask yourself, is that side included or not included? And it is not the side in between the angles, so it's the not included side that they shared. They shared this side right here in the middle. So they can be proven congruent by angle, angle, side. You just might on your test have a triangle that you can't prove congruent to another triangle, so keep that in mind. 4.7 uses isosceles and equilateral triangles, and our knowledge with that. So angles have relationships with opposite sides. Because this side is congruent to this side, two sides are congruent, making it an isosceles triangle. So we know the opposite angles, the base angles, are congruent as well. So x is equal to 65 degrees. That one was a fairly straightforward example. The second example is less so. So all three sides are equal, which makes it equilateral. And we know that equilateral triangles are also equiangular. So I know that all three of these angles are congruent. So this one is also 5x plus 10. And this angle is also 5x plus 10. So here I have, I'm writing it out, 5x plus 10 plus 5x plus 10 plus 5x plus 10 equals 180 degrees. So this is 15x plus 30 equals 180. 15x equals 150, and x equals 10. So that's just using what you know about sides and angles and their relationships as far as isosceles and equilateral. And our last section was the odd section out of this chapter that uses transformations. So if I were to translate a point or a figure to the right, you would see x plus, and to the left you would see x minus, up you would see y plus, and y minus. So an example of that notation is right there, x minus 2, y minus 1. So if I wanted to shift my graph, this would mean left 2 and down 1. That's what that would mean. So I simply take my x value and my y value, and this is going to be my new point, a prime. So I do 3 minus 2, comma, y, which is negative 5 minus 1. So your a prime, your new point, your image, is 1 comma negative 6. Alright, so you might need to be able to use a rule like this, use that notation, or actually find it. So if your original point is 5, 0, and your new point, x prime, is 0, 3, then your rule would be, let's see, to get from 5 to 0, you subtract 5, and to get from 0 to 3, you add 3. So you might need to find a rule. X-axis reflection means that you take your point, you keep x the same, and make y the opposite. So I'm going to keep x the same and make y the opposite. So my image, my b prime, is going to be 3, 5. And y-axis reflection, I take the opposite of x, so that's going to be negative 3, and I keep y the same. You would see this reflection if you were to actually graph the points, and you may have a problem or two where you have to graph multiple points and then translate all of them to find a congruent figure. So this is the chapter 4 review. Hopefully you guys got something out of this video. If you have any questions, please feel free to see me before or after school, or email me with questions. Good luck studying.